Your next video lesson is the second half of transformations. We are going to build off of the last lesson, reviewing transformation notation, and actually work on graphing them, which, again, I'm assuming everybody loves graphing. And if not, you're going to love it by the end of the course, hopefully. So if you need a minute, maybe grab some graph paper or a ruler. When you do have to make graphs on your tests, you are going to have to make them neat and tidy, or if you have graph paper, that can work too. Our learning goal, we're just going to transform and graph several of the parent functions we've looked at. Not all of them, just some of them. The same rules are going to apply. Our first example, we're going to graph f of x, and a good idea when you start is to identify what the parent function is. So looking at that, one of the key things that you should see or should stand out to you is the square root. And that tells you that the parent function is the root function. Now you kind of have an idea of what the shape might be or what the shape might look like. You might also want to refer to what the parent points are for that. The next thing you're going to want to do before you come up with your txy, just like last lesson, take a look and see, is there a value attached to x, which in this case there is. So we got to common factor that out. So let's start there. I got to common factor out that 3, which will leave me with 3 and then bracket x plus 1. And then outside our square root plus 4. Now we have an a, a k, a c, and a d. We're ready for our txy. So our k value is right there, x over 3 minus 1 because of that. 2y, that's our a, plus c. Now we're going to have to go back and refer to what are our parent points for the root function. So we are going to transform. Remember, you can't take the square root of a negative, so 0, 0, 1, 1, 4, 2, and 9, 3. And if we want to do another one just for good measure, we can. The next nice square root is 16. And we're going to put all of those points through the transformations. At this point, if you would like, pause the video, put all those points into your transformation notation, transform it, come up with the 5 points, and then hit play again and come back and make sure you did it properly. If you pause, welcome back. You should have got the following coordinates. -1, 4, -2 thirds, and 6. Remember, advanced function students, we want fractions, 1/3 and 8, especially if they are non-terminating decimals, like 2/3 and 1/3. 2, 10, and 13 over 3 and 12. And even just looking at that, it's not going to fit on our graph. So we don't even really have to include that one. My pen seems to be lagging right now, so we'll just wait. There we go. So if you got that all right, give yourself 4 high fives. X and Y, plot our points, -1 and 4, -2/3 and 6, roughly there, 1/3 and 8, roughly there, 210. We don't really need the other one. So there's our graph. Don't forget to label it. There's f of x. And remember, this is the root function, so it, at this point right here, I'll highlight it. At this point right here, that's like your starting point. Don't put an arrow going the other way, because remember, the root function does not go any further past 0. And that point that we got, -1, 4, was our starting point mapped to that new point. Excuse me. Our next one, we're going to graph. Again, maybe a good idea to identify the parent function. And as soon as you see an exponent as the variable, so if we take a look here, my exponent is this x over 2, that is your indicator that it's the exponential function. And again, you could pick your base as anything, but this has a base of 2, so this is 2 to the x. Next, do you have a number attached to x? And we do. It's x over 2. We got to get that away from the x. It's got to be x by itself. So we are going to have to common factor out that 1/2. So 2, 2. Our exponent, common factor out that 1/2, leaves us with x minus 2 plus 2. Now we're ready for our txy. Remember, this is our base, so that's not our a, or k, or d, or c. We have there's our a, k, d, and c, just to help remind you. So you could write this, remember, as x over 1/2, but dividing by half is the same thing as multiplying by 2. So 2x plus 2 and 2y plus 2. And our parent points, -2 and 1/4, -1 1/2, 0, 1, 1 and 2, and 2 and 4. Same idea. If you want to challenge yourself, put all those parent points through the transformation, see if you get the same thing as me. Hit pause, come back. If you hit pause, welcome back. Hopefully you got these, -2 and 5 over 2. 0, 3, 2, 4, 4, 6, 6, 10. If you got all those right, give yourself a one-handed high five. Let me know how that goes. X and Y, plot our points. 5 over 2 is just 2.5, so -2, 2.5, roughly there. 0, 3, 2, 4, 4, 6, 6, 10. Now, if you kept going, so -3, -4, you're welcome to. You're going to get closer and closer to 2. So don't forget, the exponential graph more or less looks like this. And remember, it has a horizontal asymptote at 0. This has been shifted, because of this, it has been shifted up 2, which means your horizontal asymptote is going to move up 2. And normally it's 0, now it's going to be at 2. oops, not the eraser, we want the highlighter. So we have a horizontal asymptote dash line at y equals 2. And if you kept going backwards with the x-coordinates, -3, -4, -5, you would find they get closer and closer to 2, but we'll never get there. So we'll label that y equals 2. And spoiler alert, that just gives you the horizontal asymptote. So this gets closer and closer without touching it. And there's our f of x. Just like that, 2 graphs in the books. 2 more to go. Our next function, identifying the parent. This one's a bit tougher, but we see a fraction and x is in the denominator. That is your indicator that it is the reciprocal function, which is 1 over x. Is there anything out front of x? No, so we don't have to common factor this time. So we can go right to the txy. And we would have x, because there's no k value, minus 2, then negative 0.5a is our a value, so negative 0.5y, and then minus 1. And our reciprocals, parent points, negative 2 and negative 1/2, negative 1, negative 1. Remember at 0, something crazy happens, error, which is a vertical asymptote, 1, 1, and 2, 1/2. Pause, challenge yourself, see if you can get the parent or the translated points. Hopefully you got negative 4 and negative 3/4, negative 3 and negative 1/2, negative 2. And then vertical asymptote, you can't do anything with that, right? So it's just still a vertical asymptote, which tells you your vertical asymptote is at negative 2. And then negative 1, negative 3 over 2. And 0, negative 5 over 4. If you got those all right, give your dog a fist bump. X and Y. Let's put I like putting our asymptotes on first. And we are going to graph these types of functions in more depth in a future unit. So that's something to look forward to. But we have a vertical asymptote at negative 2, and that's from this right here. So now my horizontal asymptote, normally we have one at 0. We just kind of learned from the last one that C value moves your graph up or down. So we have negative 1, which means your graph is going to move down 1. In other words, your horizontal asymptote is going to be negative 1. So across. Don't forget to label your asymptotes. Y equals negative 1, x equals negative 2. Then plot your points. We only have a few, but we already kind of know that they should be in opposite diagonal quadrants. But negative 4, negative 3/4, negative 4, and negative 3/4 is roughly there. Negative 3, negative 1/2 there. And we know we can't cross either of those asymptotes. So, and you're welcome to find more points than what we used. But you're going to have one there. And hopefully you're thinking the other one's going to be in the bottom right. Our points should back that up. -1 and -1.5. So -1.5 is there. 0, -5/4 is there. And our coordinates back that up. So here's graph number 3. And finally, graph number 4. This is an absolute value graph. As soon as you see those vertical bars, that's your indicator. Our parent is the absolute value function. We can go right to txy. There's no k value. In fact, there's no k or d, so this is just x. And 3y minus 2, our parent points. -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. And so far, all we've said, I think, is absolute value function turns anything positive, which is not actually the case. That's just what I've been telling you so far. You will have a lesson coming up very soon that will actually explain to you what the absolute function does. So putting it through all of those transformations, you should end up with these coordinates. -2, 4, -1, 1, 0, -2, 1, 1, and 2, 4. So all this did is moved it down and stretched it. Plotting our points, -2 and 4, right there. -1, 1, 0, -2, 1, 1, 2, 4. And straight lines, and there's f of x. Good, so there's 4 graphs. Hopefully there's no questions. Very, very similar, again, to work you would have done in grade 11, just with some different functions. And like I said, if you have graph paper for your test, or you might want to make sure you have a ruler, a different color to do your asymptotes in, to make sure when it comes time for your test, everything's neat and it photographs really well and turns into a PDF really well. There is your seat work for this lesson. Enjoy your graphing.